Okay, this is just finishing up our activity in relation to absolute value function transformations. Now, as an honor student, you might not find a spot for this in your guided notes book, but this is part of our curriculum. So add it in there on a separate sheet of paper or fit it in there somewhere you have some space. Just to kind of review as we move forward into this one other transformation that we're going to cover on this video. Remember that this is our parent function of the absolute value function. This is the function before any transformation has taken place. And if we were to graph this, so just reviewing, it sits at the origin. It has a slope of 1, and it's pointing upward, as seen here. That's our parent function. Again, any move from that is a transformation. So we've then looked over here. This is what we call vertex form. We like this form because we can see all of the transformations that are occurring just by looking at the function. So let's review those really quickly as we add the new one. This guy right here, right, changed the graph vertically. This was a vertical shift. We said if you add a value on the end, so if you're adding something, then your graph was moving up that number of units. If you're subtracting a value on the end, then the whole graph shifted down. On the inside, this was our horizontal change or our horizontal shift. So this is moving the graph left to right. So our horizontal shift. Again, this one works reverse of what it looks like because we've got a negative in there. So when we're subtracting h, it's actually moving to the right on the x-axis or in the x direction. And if we're adding h, it's moving to the left. Okay. Our a value then helped us when we were graphing. It told us the slope, so we like the a value, but it also tells us if it's opening up or down. If a is less than 0, in other words, if a is a negative value, then it's been reflected over the vertex value, so we're looking at reflected, or in other words, it's opening down. So we're looking at that. And then we said, well, and if the a value is a fractional value, so if we're ignoring the negative, so if the absolute value of a, if it's bigger than 1, then that slope increased rapidly, and we called this a vertical stretch. It made our graph very tall and skinny, so it made a skinny V. And if it was a fraction value, the absolute value of a between 0 and 1, we called that a vertical shrink. And that the slope was decreasing, making a very flat V. Okay, I'm going to review that just really quickly, and then we'll talk about the change. So notice here we've got our graph. This is the parent function. It's sitting at the origin. It has a slope of 1. If I start to change the k values, right, the graph is shifting up and down as those k values change. You can see the k values on the left. Notice once I start to move the h values, so I'm going to push play on the h values, it's going to start to move it left and right and up and down in conjunction with those h and k values. So we're looking for where the vertex is moving, and then once we start to change the a value, we start to make it a little bit steeper. It increases the slope or decreases the slope as we come back towards 0. Notice it flips over as soon as I jump to negative a values. And then it's increasing and decreasing that slope. So those are all of the ones that we've looked at thus far. And again, if no transformation has occurred, then this graph is sitting at the origin. Okay. So for example, if I was looking at this number 7 equation on the left, y is equal to the absolute value of x minus 2 plus 4. There have been 2 transformations there. We've shifted up 4 because of the plus 4 at the end. And the 2 on the inside means that we shifted right 2. So I would move up 4 units, I would go right 2, and that's where I would put my vertex. Again, this one's opening up. So once I placed my vertex up 4 over 2, then I would count a slope of 1 in both directions. Now, notice what changes if we add one more transformation. So I'm going to show you what that equation looks like. I've added it right down here. We can also write our vertex form in a similar way where we have added in that b value right here. This changes or affects the horizontal change. So notice I put a c value right here. I no longer put that h that represents the vertex. The C value in this case, right, is not the H value because this B is affecting every one of our horizontal values, our X values. And the B is going to add one additional transformation. This is going to be a horizontal stretch or shrink. So the other ones were vertical. So this is a stretch or shrink. And it's always stretching or shrinking by the reciprocal 1 over B. Okay, and we're going to look at what that looks like on the graph. If our B value is negative, so if B is less than 0, or in other words, if you have a negative, right, B, that's what it would look like. I'm going to write B is less than 0. Then it's reflected over the y-axis, so it's changing those output values. Now I'm going to show you, or changing the input value in relation to that. I'm going to show you what it looks like, and then we'll come back and do some examples with that. So here at the top I have this equation, bx minus 2 plus 4. If I go ahead and graph that, you'll notice it's the same one that we were just looking at down lower. We've went up 4 and we've went to the right 2. Now notice that's because b is equal to 1 at this point. If I start to change the b value, notice that as the b value increases in value, the graph is moving back towards the y-axis. It's actually what we call horizontally shrinking back, and it shrinks proportionally. So if I let the b value equal 2, notice that it's actually shrunk back by a half. So normally we would say that the whole graph is shifted to the right 2, but it's shrunk it back by a half. And then if we were to go and let the b value equal a fraction value, so if I let the b value equal 1/2, maybe, if we can get there. Yeah. Okay, nope, might not stop there. Notice that the vertex is out here at 4 now. It's actually stretched it away from the y-axis, though our y-intercept has never changed. So the y-intercept is still there, but this vertex has been moving, right? So it's at 4, 4 at this point. So when we graph these ones, you're going to see that it's going to shrink back and forth. One additional thing, let me show you. So again, if we have a negative b value, notice that this is reflecting it to the other side of the y-axis. So we're going to implement one example of each of these. So let's look at this first one. Let's say we have a function, y is equal to the absolute value of, let's say, 3x plus 6. And let's do minus 4 on the end here. So first of all, identifying where the vertex is going to be, we're going to just look at the transformation. So in this case, right, it's going to shift down 4. Then we look at this one, it's going to shift to the left 6. And then once we've reached that vertex, right, the value, it's going to have a horizontal shrink, because it's the reciprocal, by 1/3. Okay, so if we look at this and we're going to graph it, again, we're going to start here at the origin. Let me use the laser. There we go. We'll start here at the origin. We're going to go down 4. So I'm going to end up 1, 2, 3, 4 right here. I'm going to go left 6, 1, 2, 3, 4, 5, 6, and I'm sitting right here. And then it's going to shrink back by 1/3. Well, 1/3 of 6, so this is how far I went. 1/3 of 6 is 2. So I'm actually going to shrink back to 2, and that's where my vertex is going to go. Okay, so right here. And then just like before, we use the 3 to help us identify how to graph it with the slope. So in this case, our 3 is our slope, so we go up 3 over 1, up 3 over 1, and we can continue to do that to graph our function here. Okay, missed it. Oops. Let's do one additional one. I'm going to throw just about everything at this one. So we're going to go y is equal to negative. Let's put 1/2 in here. X minus 2. And let's do plus 4. So looking at this one, again, you're going to identify those transformations. So again, if we're looking at this one, this is going to go up 4. Okay. We look at this one, this is going to go right 2. And then notice this guy right here is a horizontal stretch because we do the reciprocal of 2 or by 2. Okay. And then don't forget this negative out here. This negative right here is going to flip it upside down, right? It's going to reflect it. So this is going to open down. I'm going to add one more negative in here. I apologize. I know I should have done it earlier, but I'm going to add a negative right here on the 1/2 so that we can see what that looks like as well. Remember, if we add this negative right here, this is going to reflect it over the y-axis. Okay, so I'm going to read this function from right to left. I'm going to start here where I'm going up 4, and then I'm going to go right 2, and then I'm going to shrink back, I'm going to reflect, and then I will flip it upside down. So we're kind of going right to left. So here I start at the origin, I'm going to go up 4. So we're going to go 1, 2, 3, 4. So we're there. We're going to go right 2. Okay, so I'm sitting right here. Then I'm going to stretch it by 2. In other words, I'm going to double the distance. So I'm at 2. If I double that, that means I go out to 4. Now I would be sitting here at 4. However, I'm reflecting over the y-axis. So instead of being at positive 4, I'm going to jump over here to negative 4. Once I'm here, I then can use the slope that's sitting right here, 1/2, to graph my function. Remember, it's going to open down. So we're going to put our vertex there. And we're going to use our rise over run. So I'm going to jump down 1 and then run 2, down 1, run 2, down 1, run 2. And we can create our function here. Again, the goal is to be able to pull apart those transformations one at a time so that we can construct that function. And we can do that using the different pieces as we pull that apart.